Fluids. They are everywhere. The air we breathe is a fluid. Molasses is a fluid. Salad dressing is a fluid. And water is a fluid. But what exactly is a fluid? A flowy thing? Well, kind of. A fluid is simply defined as a substance that continually deforms or flows under an applied shear stress. Wait, what? That didn't help me understand fluids at all. Well, to understand fluids, we're first going to need to understand force. A force is a push or a pull. The shark applies force on the man when the shark pulls or pushes the man. A force that is parallel to the surface that a body is being moved across is called a shear force. Shear force creates shear stress, which is the amount of shear force per unit of area. Inside a body, there are multiple particle layers. When there is shear stress, the top particle layer moves faster than the bottom particle layer. This pushes the top of the body forward and the bottom of the body back. When the top of the body moves in a different direction than the bottom of the body is deformed. Oh, I get it now. Any substance that always flows under shear stress, like gravity, or a push with a spoon, is a fluid. But why do some fluids flow quickly and others slowly? When the particle layers slid over each other, there was friction generated between the particle layers. Different types of particles would have different amounts of friction. This friction causes a resistance to gradual deformation by shear stress. The fluid doesn't want to flow. We measure this resistance using viscosity. Fluids with high viscosity have large amounts of friction between particle layers, high resistance to shear stress, and flow slowly. We usually think of them as thick fluids. On the other hand, fluids with low viscosity have little friction between particle layers, low resistance to shear stress, and flow quickly. We usually think of them as thin fluids. Honey is an example of a fluid with high viscosity. As you can see, it is flowing very slowly. Water, on the other hand, has a low viscosity. It flows quickly. A common type of fluid is called a Newtonian fluid. A Newtonian fluid's viscosity always stays the same. The shear stress has no impact on the fluid's viscosity. Water is a Newtonian fluid. It does not matter if I apply less shear stress to the water or more shear stress to the water. The viscosity stays the same. Fluids aren't just Newtonian. There's also non-Newtonian fluids whose viscosity varies with shear stress. One type of non-Newtonian fluid is called a dilatant or shear thickening fluid. As shear stress increases, the viscosity of a shear thickening fluid increases. Here, a shear thickening fluid is being made by suspending cornstarch in water. When I pour the shear thickening fluid, there is little shear stress on it. It has a low viscosity and flows nicely into the cup. Here, I apply little shear stress with my spoon. The fluid again has low viscosity and flows around the spoon. Now, watch as I put more shear stress on the fluid by hitting it with my spoon. The viscosity of the fluid drastically increases. The fluid almost acts like a solid. Now, I put even more shear stress on the fluid by hitting it with a cup. The viscosity again increases. The fluid almost acts like a solid. So, why does this happen? First, we have to remember that we have suspended the cornstarch in the water. Here, I have represented the water with marbles and the cornstarch with blocks. When there is little shear stress, the cornstarch and the water are able to slide past each other and flow with a low viscosity around the spoon. When there is much shear stress, the water slides past the cornstarch, but the cornstarch is unable to move. An area with mainly cornstarch forms, creating a barrier. The fluid's viscosity increases. Opposite to shear thickening fluids are shear thinning fluids. As shear stress increases, a shear thinning fluid's viscosity decreases. Ketchup is an example of a shear thinning fluid. When there is little shear stress on it, it has a high viscosity and does not flow easily. However, once I increase the shear stress by hitting the ketchup bottle, ketchup's viscosity decreases and the ketchup flows out of the bottle easily. Why does ketchup act like this? Ketchup is made of tomato particles suspended in vinegar. Here I have modeled the tomato using sand and the vinegar using marbles. When there is little shear stress, the tomato and vinegar both clog up the bottle. However, once the shear stress is increased, the tomato is deformed and both the vinegar and tomato can exit the bottle. The viscosity of the ketchup is decreased. Now that you know about fluids, go and find some. Remember, a fluid is any substance that continually deforms or flows when a shear stress is applied. Does the fluid that you found have a high viscosity or low viscosity? Is the fluid you found a Newtonian fluid, a shear thickening fluid, or a shear thinning fluid? Remember to ask all of these questions when you encounter your next fluid.